Hello everyone and welcome to another video on African Tech Gurus. This is your number one channel where we learn technology by doing. If you are new to this channel, welcome. We appreciate you and please do us the biggest favor and subscribe to our channel and click on the notification button so that each and every single time we upload a new video, you are immediately notified. If you are a returning subscriber and a returning viewer, thank you so much for clicking on our videos. It helps our channel and it also helps us give better services to you. So today we will be covering debugging. Debugging is one of the concepts they want us to learn, and today we will be discussing what is debugging, what are the different types of debugging, and even have an example of how to read error messages that we will encounter frequently in the future. So if you look at the resources, they have given us two resources to look at. One is debugging and the other one is rubber duck debugging. And also they're also telling us that debugging is the process of finding and fixing errors in software that eventually prevents the software itself from running correctly. So if we move to this link, which is the first one that they have provided, it gives us a brief view of what debugging is, and it gives us a bit of history and where it is coming from. And the funny thing is that the term debugging was first discovered by a lovely lady, Admiral Grace Hopper, in 1940 when she was working on a Mark II computer. And how she discovered this is there was an actual bug, which is a moth that was stuck in a relay, and thereby it prevented the operation. So that is where the first term debugging came from, and there it was an actual bug. But now how we use it in software and in the computer and technology world is it is in terms of the errors that we will encounter and the faults that we will encounter on our day-to-day basis when it comes to the actual running of the code. So I have prepared some introduction and some things for us to look at. So if we are to start at what is debugging, we have mentioned it is a process of finding and resolving the errors, the bugs, and other issues that we will definitely encounter in code. So most of the time when we write our source code in whatever language that you will be using, it might not run smoothly, and sometimes it will have some impediments and some areas where now the code completely refuses to execute, and this now are the bugs that we need now to, one, find, and two, solve them. And the next thing that we can now look at is what are some of the methods that we can use to debug manually. So one of them is the print statement, and what the print statement does is here we are adding print statements in the code to display the values of variables and the execution flow that can be very useful in debugging. So this specific method, it is very helpful when you have a small piece of code and you want to see the value of the variable at the different points in the code. So if you have a very small program or a very small source code, this is a very good debugging method to use, and specifically a manual debugging technique or method. Another very common one is the use of a debugger, and a debugger is a tool that will allow you to step by step go through your code lines, and it will set breakpoints and it will examine the state of the different variables that you add and so much more at a deeper level. And it also helps you move through the code rather quickly and in a more organized manner. So it is very good and a very excellent tool when you want to track down very complex issues. So some issues will be very simple, we can use the print statement, but some are very complex and it will be very hard to use the print statement method. So here we use a debugger. The third very common method that can be used is code analysis. So this is the manual review of the code and it can help identify any potential issue. So it is very useful when you're dealing with logical errors, and logical errors are some of the most difficult errors that you will encounter because your program will run but it will not give you the output that you're looking for. For example, a logical error will be if you want to do 3 plus 2, which will give you 5, but at the end of the day you actually put in a wrong symbol and you put 3 minus 2, which gives you 1, your source code or your program will definitely execute, but it will give you the wrong error. So in this case, it is very good to use code analysis. The other type of method that you can use when you want to debug is code isolation. And in this one, if you can reproduce the issue in a smaller code snippet, then you can isolate the problem and focus on fixing just that problem instead of the entire source code, which is sometimes can be very, very big. And this particular method can be useful when the code base is very large. Some softwares and some programs are very, very large, and it is not feasible to actually go through each and every single line one by one. And code isolation is one of the very useful methods that you can use. And most of the time, you are not sure where to start debugging. So code isolation will definitely help you in those two scenarios. The fifth method is divide and conquer. And here it is when dealing with a very complex system. So what you do is you divide it into smaller components or smaller parts. And at the end of the day, this can help you identify where the issue or the errors and the bugs are coming from. So what it involves is it's breaking down the entire source code into smaller components, and then you go ahead and test each separately. So what this does is it helps you work around through the code instead of going line by line, but more in terms of blocks or chunks of it. So if a chunk is okay, you know that bit is okay, and you've done a specific percentage or covered a specific percentage of your entire source code, and you move to the next. So with this specific one, it is very stepwise, and it helps you move in a very logical manner. So even if you don't have an entire day to sit and debug or the entire time, you can actually use this to work through your code in sections. The other very common one is logging. And logging is where you add log statements to your code that can help you in debug. And these logs will provide you with very useful information about the execution flow and the different states of the different variables that you have used at different points in your code. So think of them as kind of little signs that you put along in your code so that later on you're able to debug your code. So another very common method that we have been told to look at is the rubber ducking debugging, and there is some content that they have also provided for us. Please make sure you read through this for it to help you understand code better and what it does. This is the rubber ducking method. So at the end of the day, what rubber ducking is, it is a technique that is used by programmers to help solve problems and debug the code. So at the end of the day, the idea behind it is that sometimes the best way to find a problem in the code is to explain it to someone else, or in this specific case, it is a rubber duck. As funny as it sounds, it's very effective. And the process in this case, in rubber duck debugging, is a programmer will explain the code and the problem they're trying to solve in detail. So at the end of the day, when you try and explain the concept or an idea to someone or an error to someone, you at the end of the day, you're able to understand it and internalize it more and more. And in this case, the programmer will actually go through each specific line of code and explain what that line of code does. So as they are explaining this code to this rubber duck, they will start noticing the mistakes that they have actually done and the oversights that they have actually overlooked in their code, and they will actually be able to spot their faults. So it is very efficient because at the end of the day, you might not be able to get someone to explain it to because everyone is busy doing something else. And this is very effective because you will talk to the rubber duck as it's a person or as it's someone else who's standing beside you. So The whole concept is this rubber duck is supposed to serve as a sounding board, and the process of explaining the code out loud will help you as a programmer to identify the root cause of your problem. So by the end of the explanation to the duck, now the programmer will be better placed and will have a better understanding of the problem, and most likely at the end of it they'll have a solution. So rubber ducking method is a very, very popular and very effective debugging method. So please make sure that if you're not able to use the other methods that you have looked at, please take up this rubber ducking method. It is very useful, and if you make it your daily practice and inculcate it into your programming lifestyle, you're going to save yourself a lot of trouble now and also in the future. And it is very, very useful, especially when you're working on very large blocks of code and very complex problem, because it will help you slow down and think through the code in a more careful manner, and it will help you consider different perspectives so that you're better placed to find a solution. So now the next thing that we want to do is actually learn how to read and see the different errors that we can encounter and how to go about it. So let me open my terminal. I had earlier opened it. So I want us now to create an actual file that has an error and run it and see how we can identify the errors and how we can actually remove these errors. So I want us to create a file. We need to first check where we are at. We are in root, and let us list all the files that we have. These are the files that we have. So I want us to create a file called hello.c. And in hello.c, we are going to put in a wrong actual code, which is this. So normally this will run by itself, but I want us to put an intentional semicolon there and see if it will run or not. So I've copied that and I've pasted it there. Let me see. And the next thing we need to do is actually run this code, and we are going to use GCC to run it and execute it, and it will give us an error. So there it is. So the error that we're getting is the name of the file, what I have highlighted, and the line of code that actually has that error, which is line 3. So if we were to look at our code, which is hello.c, we can use cat to view it. We actually do have these 3 lines. This line, this is the first line, this is the second line, and this is the third line. So the error that it is giving us, it has encountered an expected identifier or an parenthesis before the curly bracket. So what we need to do is we need to check our code before the third line that has the first curly bracket. So now if we go into our file and actually remove that item or that character that we have identified, it will run without errors. So at the end of the day, GCC will help you execute, and it will also help and point out where the problem or the error or the bug is occurring, for you now to be better placed to understand what the error is and for you to fix it. So now let us remove that and save it. And once we save it, now we can run, and this time it should run successfully. So at the end of the day, you will get and encounter errors like this, and that is how you're supposed to identify them and how you're supposed to fix them. Some might not be very direct and need you to further understand the specific errors and what is happening, and that will come with time. The more you encounter errors, the more you fix them, you become more and more knowledgeable. So one thing that I want us to look at now is this GCC and what it means, and the specifics are very detailed. So at the end of the day, we have some code that we have used, some GCC code, and let's look at what it has actually done. Let me minimize this. So the first option that we have is the wall option, what I have highlighted in blue. So what this does is it enables the GCC compiler to have warnings, and these warnings will help us catch any potential bugs and issues that are in the code. And the next one is the W error, which I have highlighted there. Is it will treat all compiler warnings as errors. And at the end of the day, what this means is that the compiler will stop the compilation process and process any warnings that have been generated. The other one is the W extra. What it does is it enables additional compiler warnings beyond what the what the dash wall has provided. So at the end of the day, it provides even more thorough error checking. The fourth one is the dash pedantic, and what this does is it enables strict ISO-C standard conformance, and what that means is at the end of the day, the compiler will issue warnings for code that does not conform to standard procedures that have been set out. And lastly, we have the dash std equals GNU89, and what this does is it sets the C language standard to be used during the compilation to the specific, which is C89. And it is very useful because it will ensure compatibility with older versions of code that may not conform to newer C standards. So at the end of the day, this is how you check your errors. This is how you understand what the errors are doing, and you can be free to use any debugging method that you want to use depending on the specific problem that you're looking at, and also depending on the complexity of your issue. So I hope this has been great and this has been successful. If you've liked today's video, please give it a thumbs up. Please share with a colleague, with a friend, so that at the end of the day we are stronger and better African tech gurus, and we are able to build solutions for our home and for our countries and for our continent at large. At the end of the day, I'd also like you to subscribe to the channel. It supports us, it encourages us, and it helps us provide better services and better content for you. And that is it for today. Until next time, happy coding.